So what the midpoint does is it kind of throws a little wrench in the situation with this segment addition. But it's not too bad, but you're going to see two different types of segments today, and you solve them two different ways. And the hard part's just figuring out which way do you have to do it. And that's why we're going to walk through a couple of extra little examples today. So what a midpoint is, for some reason in your note packet, it doesn't give a really good spot to define the midpoint, so I'm making one. So what do you think when you see the word midpoint? What does that make you think of? If you had to break apart that word. It's a midpoint. And if it's of a segment, where would it be? In the middle. Good job. So the midpoint of a segment is a point in the middle of a segment. And we're going to be doing more with midpoints next week because there is a formula that goes along with it. If they are not nice and straight segments like left and right, up and down, if they're diagonal, we've got to do a little bit more work. So like for example, if we had this segment right here, X, Y, and if X is at 0 on a number line and Y is at 10, where would the midpoint be? At 5. So this would be considered the midpoint. Now, what the midpoint does, this point right here cuts your segment into two equal lengths. And in geometry, we don't use the word equal, or I kind of do when I shouldn't because that's what you're used to. You're going to see a new word get kind of thrown around there called congruent. The word congruent basically is the geometry term for equal. So if you hear congruent, you have to automatically think equal. It's going to say the word congruent in like from now until June. You're going to see congruent, and it just needs to kind of be one of those things that you automatically know, well, if two things are congruent, then two things actually are equal to each other. So the midpoint is going to be the halfway point, or what it does is it cuts your segment in half. How they notate that or how they show that on a segment, if this is X, Y, and then if this is your midpoint, Z, they do have some little like notations. And if we don't have numbers here, like 0, 5, and 10, we know that 5 is in the middle of 0 and 10. If we don't have any numbers, which today you're going to have some variables, they're coming back a little bit, bring back that algebra. They put these little dashes. These dashes right here tell me, you, anyone looking at here, that this length from Y to Z is equal to or congruent to this length from Z to X. So that little marking right there means congruent. There are a lot of markings that you're going to see throughout this first unit. We've got markings with segments. We've got markings with angles. But this little dash right here, this dash shows you and tells you that this length and this length are equal to each other. So XZ would be equal to YZ. So today, if you are solving something with a midpoint, you actually have two equal segments. And that's where it gets a little confusing because sometimes you're doing segment addition when you're adding your segments together. Sometimes you're going to actually be taking your two segments and setting them equal to each other. And you've got to kind of take a step back and figure out which one is which. And I'm hoping that I can help you to figure that out as easy as much as I can. But sometimes it's just got to be something that clicks in your brain. So what's kind of weird, again, is that you're actually going to go to the very back of your note packet. The very last page. And go to example 3. Why it's here, I don't know. So for example 3, in the directions, they tell you C is the midpoint of, there should be an AB there. So they're telling you that this is the midpoint. So because it's a midpoint, that means that you know that this length AC is equal to that length CB. So we know because it's a midpoint that AC equals BC. We know those two lengths are equal to each other. And in the directions, they want you to find the length from A to C, the length from C to B, and the length from A to B. So they actually want you to figure out what those lengths are. In order to find out what those lengths are, though, what do we need to do first? Solve for X. And notice here, they're not going to tell you all the time, solve for X, then plug it back in. They're going to tell you to find the lengths, which basically means you're going to have to solve for X and then do a couple of extra steps. So yesterday, when we solved for X, we would have added these together and set it equal to the length from A to B. They don't tell you the length from A to B, and they will never do that in a midpoint because you actually don't need that information in order to solve for X. We know that since it's a midpoint and it tells us it's a midpoint, that this length, 2x plus 1, is equal to this length, 3x minus 4. So when you have a midpoint, you will probably, well, not always, but you may have x's or variables on both sides of your equation, but you're not going to be adding lengths together like we did yesterday. So that's kind of the weird thing for today, is it does evolve a little bit. So now you have variables on both sides of the equation. Me personally, I would move the 2x over to the right first by subtracting it. So then I have 1 equals 3x minus 2x is 1x minus 4. And then last step would be to add 4. And then you would get x equals 5. Which it's gonna hurt you for the first couple of days when you get used to this, because you're gonna think in algebra we got x, we're done, but we're not. The directions don't even want you to find x. They want you to now figure out what's the length from A to C, what's the length from C to B, and then what's the length from A to B. The best part about midpoints is you technically only need to find one of these and you're done. Like, you can find everything else. And hopefully some of you might figure that out quicker than others. So if I want to figure out the length from A to C, if x equals 5, you're going to plug and chug it in, substitute it in. There's the mathy term. So you do 2 times 5 plus 1. 2 times 5 is 10. 10 plus 1 is 11. What's the length from C to B? 11. I don't even have to plug it in because this is a midpoint. If this is 11, this is 11. That's why we just set them equal to each other. And you can kind of check it if you don't trust me. 5 times 15 5 times 3 is 15. Minus 4 is 11. And then what's the length from A to B? 22. So once you find one of them, you can find them all. It's the only new thing today. You've got to kind of take a step back and see, do I have a midpoint or am I using segment addition? So grab out that worksheet from yesterday. I had you keep it, and I wanted you to flip to the back. I have 2 scenarios that I'm going to throw at you. Let's see if I can zoom out a little bit. This is all we're doing these are like examples for you to try on your own. But these are examples I want you to do on the back of that worksheet. These are the 2 types of problems over the last 2 days now that I've introduced to you. So for the first example, I give you a segment, and then I get like a couple of little letters there. I don't want to give away what's going on because that would take away the whole point. For the first example, example 1, we'll call it, I want you to find X, and then I want you to find the length from A to C. And then for the second example, I only want you to find X. So take a look at those. If you couldn't find your worksheet from yesterday or it disappeared or something, do it on a separate sheet, but see if you can figure out how to do those. Try it out today. And if you have questions, make sure you get them answered. So the difference between example 1 and example 2, that's kind of what you needed to look at these and realize that they are two different types of problems. Example 1 has these little dashes on there, which lets you know that B is a midpoint. And if B is a midpoint, then you're going to be setting two things equal to each other. The problem came in example 2. Some of you did this, and that's okay. Is you thought example 2 was like example 1, and you set these two equal to each other. If you would have set these two equal to each other, you get a really junky, nasty decimal. So I think that was some of your red flags. Something's not right. In example 2, I actually gave you 3 pieces of information. I gave you that AC is 105, this is 47, and this is 3x plus 10. You need to use all of the information that you're given. So in example 1, you're only given 2 pieces of information. And if you have to set up an equation with 2 pieces of information and they're equal to each other, you would set these two equal to each other. You have to have an equal sign in order to solve an equation. So that's what you would have had to do. Now, since variables or since x's are on the left-hand side, I'm going to bring my other x's over to the other side. And then I get 5x equals 25. And then to undo the multiplication, you're going to divide by 5. And you get x equals 5, which is one of the things that I wanted. But then I also wanted to know what the final length from A to C is. How did you find the length from A to C? What did you guys do to make it kind of easy on yourself? Sam?
I just found AB and then knew that BC would be the same and added those together.
Perfect. So you took the 5, plugged it in here. So 9 times 5 is 45. And if both of those are 45, then you just basically like double it. So you find AC to be 90. Any questions on that? Good. So the difference for example 2 is that I now am giving you 3 pieces of information and you need to use all 3 pieces of information. So in example 2, I do not have a midpoint. I don't have 2 pieces that are equal to each other. So that means that you're going to have to add them together. What I always do when I'm given pieces of information, especially with these segments and knowing that I'm looking for segment links and I'm probably going to have to add them together, is I want to figure out what I'm going to be setting it equal to first. And it's always going to be equal to the longest segment out of what's given here. Like if I were to like bust out a ruler and measure it. So this is like kind of a small segment. This is considered a small segment. All the way from A to C is the longest one. So I'm going to equal it to 105 and add the other 2 together. 47 plus 3x plus 10. I'm about to do some crazy mental math here because I don't have a calculator. Here we go. So when I'm solving, I'm going to combine like terms. 3x has nothing to combine with. 47 plus 10, use the signs that they have, gives you 57 equals 105. Then you just have a 2-step equation. Subtract 57. 3x equals 48. And then to get x by itself, you divide by 3. 48 divided by 3 is 16. Pretty impressed with myself. Still got it. 6 months off and I still got it. And this one just wanted you to find x. So these are the 2 different types of problems that you're going to